All right, we're going to start our review video for section 7.3. That's chapter 7, section 3, and we'll start with our learning target for this area. Learning target is find the area of composite figures. So we're going to be taking some figures and looking at their shapes and building them into shapes we can work with, and then calculating their area. So a composite figure is a figure that is made up of two or more shapes, two or more recognizable shapes. Here's a series of equations that we'll need for you to have. So you'll probably want to take a few minutes and write down these equations. A parallelogram, the area is base times height. A triangle, the area is 1/2 base times height. Trapezoid, area is 1/2 the height, 1/2 times the height, times base 1 plus base 2. And of course a circle, area is equal to pi r squared. Well, let's work with some of these. Jump right into an example here. Here's the find the area of this composite figure. As I look at this, I'm going to see that inside of here is a rectangle. So I'm going to find the area of that rectangle. Area is equal to base times height. So area is equal to 12 centimeters times 6 centimeters. So the area here becomes 72 centimeters squared. Now I'm going to look at this circle, or half circle, and I'm going to say the area of this half circle that I've colored in here, area of the circle is equal to, if I remember the area equation for a circle, it's pi r squared. Since I'm only dealing with half of the circle here, I'm going to take that number and divide it in half when I'm finished. So area is equal to pi times the radius. Well, this side is 6, so the radius here would be 3 times 3 squared over 2. But you know what? I think I am going to save that divide by 2 because I've got the same shape over here. So I'm going to skip the divide by 2, and I'm going to say area of both of those semicircles added together is equal to pi times 9. And if I look at pi times 9 on my calculator, I get 28.27. So it becomes 28.3 plus the 72. So 28 plus 72 comes out to be 100.3. The area of this then is 100.3 centimeters squared of that shape. And I did it by finding the area of these two half circles plus the area of the rectangle. Moving on to another problem. Very similar problem, but in this case we only deal with half one semicircle. So I'm going to say the circumference, the area of the circle. The area of the circle is equal to pi r squared. In this case, it's pi times 1 squared. Pi times 1 is 3.14 times 1 times 1. But I can only use half of that this time because I am only dealing with a half a circle. So pi cut in half is equal to 1.57. So that's 1.6 feet squared. Now I've got the big rectangle here, and the area of a rectangle is equal to the base times the height. So 7 feet times 2 feet. 7 feet times 2 feet is 14 square feet. Plus the 1.6 would be 15.6 feet squared. 15.6 square feet. Okay, getting a little bit more complicated here, a little bit, but still laying on the same idea. I'm going to find the area of the rectangle, and then I'm going to add to it the area of the triangle times 2. So let's go area of the triangle. According to our equation, if you look back, it is 1/2 the base times the height. So it's 1/2 the base here, which is 5 feet, and the height, which is 2 feet. So 5 times 2. All right. 5 times 2 is, of course, 10. 10 times 1/2 is 5. That's for one of the two triangles. I've got two of them, so I'm going to double that. So I'm going to say area for the two triangular shapes is 10 feet squared. To that, I'm going to add the area of this big rectangle, and the area for the rectangle is 7 feet base times height, 7 times 5. So it's 7 times 5, which is 35. So 35 is for the rectangle, 10 is for that, 35 plus 10 is 45 feet squared, 45 square feet. Okay, again, we're going to be working with a rectangle and two triangles. If I look at the triangle, it looks like the height of the triangle, according to the drawing, is 6 feet. And the base of the triangle is 7. So I'm going to say that the area of a triangle is equal to 1/2 the base times the height. So it's 1/2 of 7 times 6. Of course, since I've got two of them, I'm going to take that times 2, which in effect cancels out my halves here, and I've got 7 times 6, or the area of the two triangles is equal to 42 square feet. Now for the rectangle, the big rectangle in the middle here, the area of the rectangle is equal to base times height, which in this case is 7 times 4. 7 times 4 is 28. So I've got 28 plus 42 becomes area is equal to 70 feet squared. 70 feet squared. Looking at this one, I want to ask to find the area of the shaded part. I think I'm going to do this one by subtraction rather than addition. I'm going to find the area of the huge rectangle, which I can see is 8 plus 8 would be 16 inches on one side, and 6 plus 6 on the other side. So this would be 12. So it'd be 16 times 12. The area of the big rectangle is 16 times 12. And let's turn to a calculator to figure that out. And that's 192 square inches. But that would be for the whole thing. I want to subtract this portion and subtract this portion. If I look at that, I can see that the triangle, the area of the white triangle is, of course, 1/2 base times height. But I've got two of them, so I'm going to take it times 2. So 1/2 and this 2 cancel out. So the area of those two triangles is base times height. And it would be 8 inches times 6 inches. 8 inches times 6 inches is 42. 42 from 192. 42 from 192 leaves 150. So the shaded region here has an area of 150 inches squared. 150 inches squared. One last one on this set here. Find the area of the square. This is a square, so I know it's 10 centimeters on each side. So if this is 3.5 from here to here, I can calculate the length from here to be 6.5. And if this side is 4, then this side must be 6 because it is a square. I'm going to find the area of the square. The area of the square would be equal to the base times the height, or 10 times 10. 10 times 10 would be 100. From that, I'm going to subtract the area of the triangle, which would be 1/2 of 6.5 times 6. And I'm going to turn to my calculator to do the one. So I'm going to go 0.5 times 6.5 times 6. And that would tell me the area of the clear or the non-shaded triangle is 19.5. 19.5 centimeters squared. The area of the whole thing was 100, so I find the difference. 100 minus 19.5 becomes 80.5 centimeters squared for the shaded region. That's the shaded region.